Our next speaker has experience in building secure and privacy-preserving web and distributed systems with cryptographic mechanisms. His research has been published in top international conferences, and his work has been acknowledged by Google and Apple. So please help me in welcoming to the stage Yaoqi, the founder of Zilliqa.
Oh. Hello. Hello. Whoa. Oh, nice meeting you guys. So this morning, Uncle Da mentioned about the future of NEO. So basically, even without sharding, NEO in the future can achieve 100,000 transactions per second. It's very exciting news. And now I'm going to present to you how we can achieve using the sharding technology. So think about in the future together with NEO and sharding, and we can even achieve higher throughput. So, so I'm Yaoqi, from Zilliqa team, and I'm the blockchain architect and also the co-founder of this company, or this Zilliqa Research. And today I'm going to present how we use sharding in Zilliqa to improve the throughput of our blockchain. For the name Zilliqa, basically we take the idea of the silicon. Since silicon powers the sort of the internet industry, we hope in the future Zilliqa can also power the blockchain platform and the industry. So this is one slide basically taken from our website, and it shows our recent results in our internal testnet. As you can see, without any knowledge of the sharding, you can look at the figure. With more nodes join our network, and the throughput can be much higher. So in the best results, as you can see, with 3,600 nodes running on top of Amazon EC2, actually we can achieve over 2,400 transactions per second. This is amazing, right? And the beauty of our system that in the future, when more nodes join the system, actually we can achieve even higher throughput. That means more nodes, higher throughput. And in the future, welcome to join our network. So since we are in this new DevCon developer conference, so here I want to share with you more the tech details of Zilliqa, and to help you to have a better understanding of the sharding, and especially the sharding in Zilliqa. Actually, we some members from our team, or our advisors, Loi Lu, you may know, the CEO of Kyber Network, and Perdi Saxena, basically the advisor of me. And they published this research paper called A Secure Sharding Protocol for Open Blockchains, like 2 years ago in CCS 2016. It is sort of the first research paper published in top security conference to discuss about the applying sharding into these blockchain areas. So after these 2 years exploration in the private blockchain systems, and last summer we decided to improve the protocol and make it to be the public blockchain. The idea of sharding is quite simple. Basically, it's divide and conquer in parallel. That means you have this big network with over 10,000 nodes or even 20,000 nodes like Ethereum today. You just divide the network into small groups of nodes, what we call shards, and within each small group of nodes, you can process different set of transactions. And later, I will explain more to you. At the same time, instead of using sharding, in addition to using sharding, we also improve the consensus protocol. Basically, we use a variant consensus protocol compared to the PBFT, this practical Byzantine fault tolerance protocol. At the same time, we also apply some new crypto primitives called this multi-signature based on Schnorr signature. And together with PBFT and this new crypto primitive, we employ our Zilliqa new consensus protocol. Basically, together with sharding and our new consensus protocol, we can improve the throughput of our platform a lot. So let's zoom into the tech part of Zilliqa. At the beginning, our network is sort of sharded into different different groups, and each group will have over 600 nodes. And after that, some nodes want to join the system or join the network. What can we do? So first, these nodes will do the proof of work. Basically, it's a similar proof of work to this Ethereum based on Ethash. The parameters of this hash function are these randomness, like the hash of the last block and this IP address, public keys, and nonce to basically increase the nonce and to change the parameters of the hash function. Finally, once you meet the difficulty level, you can get the solution of this puzzle or POW. And then here you can see we have this special part called the ID. ID is based on the result of POW. Later we will use it. Since we have so many nodes who want to join our network for a period of time, and if these nodes, some of them are maybe malicious, if these malicious nodes just want to target one shard, then they may manipulate that shard and create some malicious transactions like double spend transaction. How can we prevent that? Here is one thing. Did you remember we have the ID based on the proof of work result? Basically, we use the last several bits of this ID to decide the node to be assigned into which shard. So in this way, since for the nodes, proof of work is difficult, and for the nodes, it's also difficult for them to forge a result of a proof of work. In this way, we can ensure that all the nodes can be sort of evenly sharded into different shards to prevent such attacks. And after that, we for different blockchains and also a system, you will receive a lot of transactions either from the wallet or even from the nodes. So how to utilize the sharding features in a better way? So then we propose this transaction sharding. Basically, for different transactions, we will shard them into different shards. The idea is also quite simple. So based on the sender address of the transaction, we will shard the nodes into we'll shard the transactions into different groups. In this way, if even you want to do double spend, since the sender is the same, and they will be assigned into the same shard. If the transaction is suddenly assigned to another shard, the nodes in that shard will reject this transaction. After that, within each shard, all the nodes will basically process the transactions and do some verifications. For this part, it's quite simple. Verify the transaction, whether it has double spent and whether the sender has enough balance. Since all the nodes within shard will do this verification, after that, they will run the consensus protocol to agree on the same set of valid transactions. After that, they will aggregate these their signatures on top of these transactions and generate a macro block and submit it to a dedicated shard, which we call directory service committee. And for the consensus protocol, if you know a lot about consensus protocol, actually we can have a lot of options, like this Nakamoto consensus and also this PBFT. Like several years ago, when I first looked at this Bitcoin system, for me, the most exciting part is not about the Bitcoin, the cryptocurrency. It's about the consensus protocol. It's so beautiful. It's so elegant. It's like you can run this distributed system using like tens, thousands, or even 20,000 nodes to run distributed system, but they can still reach consensus efficiently. And I think it's already near 10 years, but there's no explicit bug of this consensus protocol. For me, it's so amazing. But there is one drawback of such consensus protocol, that is it's very slow. So you have to, every node has to run this proof of work, and right now it's 10 minutes, you can generate one block. And after that, you need another 6 blocks to confirm the very beginning block is valid. What we call 6 confirmation blocks. After that, you can guarantee that the first block is valid. However, it's very slow. It takes you maybe an hour and even more than an hour to confirm a transaction. And if you are familiar with this distributed system or distributed computing, actually in this area, like 30 years ago, there are already a lot of researchers and professors discussing about this consensus protocol. In their citing, they call it Byzantine Agreement Protocol. And one of the most famous protocols, as you may know, is a PBFT, Practical Byzantine Fault Tolerance Protocol, proposed by MIT professor Barbara. And so here I briefly show some precise of the PBFT. It has 3 phases: prepare, and commit. Why it contains 3 phases, maybe later you can ask me offline. It's a little bit complex to explain. But with this protocol, they can guarantee several things. First is all the nodes within the group, actually, they can reach consensus or reach the agreement on the same set of transactions if you're using PBFT. At the same time, it's quite efficient. Basically, if you run PBFT, you can reach the consensus agreement just within 1 minute or even several seconds. At the same time, since you don't need to do this, proof of work can do all the hashing part, and it's sort of quite energy saving. And at the end, you can have the immediate finality. That means once you conclude the run of the consensus protocol, you can immediately reach the agreement of the same set of transactions. However, the protocol also has some drawbacks. Like for PBFT MOs, you can run on top of 100 nodes because the communication overhead is O(n) squared. And at the same time, the setting in PBFT is a sort of a permission. Each node has to know the other nodes at the beginning, and then they can run the consensus protocol. And that's why, after that, we also apply some advanced crypto primitives to handle with the signature part. For the signature, most of you may know that the digital signature, the public key, private key system, basically you use for your wallet. And for one piece of information, you can use a private key to sign it, and later people can use your public key to verify it. It's the traditional signature scheme. The drawback of this scheme is that if 100 nodes sign the same set of information, it will generate 100 signatures, which you can see is linear to the number of nodes. This is not what we want. And later we basically employ this multi-signature approach. It's based on Schnorr signature. The details is a little bit complex, and here I can give you the basic idea. The basic idea that you can have 100 nodes to sign the same piece of information. But after that, the algorithm will have one more stage, basically aggregate all the signatures into one signature. In this way, even you have 100 nodes to sign the same piece of information, and you just generate one signature. And later, people can also verify the information, use all the nodes' public keys and to verify it. So the benefit of using such multi-signature is that first, the signature size is quite small. Instead of linear to the number of nodes, it's sort of constant size. At the same time, with the signature, you can also have this low communication overhead, since the message size for each phase to be transmitted is also small, and in total, the number of messages or the total size of the communication overhead is quite small. As a summary, so basically, within one shard, we first process the transactions by all the nodes, and then they reach the agreement using a variant of PBFT on the same set of valid transactions. After that, they sign the same set of transactions and using this multi-signature to generate a small signature on top of the same set of transactions. So basically, after that, as I just mentioned, there is a delegated shard called Directory Service Committee. It will run the same consensus protocol to agree on the same set of macro blocks, basically proposed by different shards. And there's another interesting part that so for different shards, they process different transactions, right? But for the DS shard, actually, they don't really do the verification of a transaction again. They just verify the signatures of these macro blocks proposed by the different shards. And later, they can run the consensus protocol and sign on the same set of macro blocks and generate this final block. Final block later will be broadcasted to different shards, and within different shards, they can do another broadcast to different nodes. And in this way, all the nodes will get the latest status of the whole network. In the meantime, since all the nodes only get the final block, say sort of the signature of the macro blocks, but at the same time, they also need to synchronize with the whole network about these transaction bodies. Transaction bodies means A sends some money to B, B sends some money to C. And for this part, we can do it asynchronously. So basically, different shards, they can basically forward the transaction body to the other shards asynchronously when they receive, at the same time when they receive the final block. Combining all the different pieces we used in the Zilliqa, we actually can achieve this high throughput. What you just saw, basically 2,400 transactions. And in the future, when we release the public testnet or mainnet, when nodes join, we can have a higher throughput. Actually, when we consider these solutions about the consensus protocol and also this signature part, we actually also have some other considerations like this low energy cost. As you can see, we do POW periodically. It's not like all the nodes just doing POW for all the time. They just do the POW at the beginning of the epoch. After that, all the nodes will be assigned to different shards. They will do the real stuff, process transactions and run consensus, and then submit the macro blocks, and then later will be syncing with the other nodes. At the same time, since all the nodes just run this PBFT like consensus protocol, and then we can basically distribute the rewards evenly to all the nodes based on their signatures or the different things. It's not like Bitcoin or Ethereum, just winner take all. Here, all the contributors, they can get rewards evenly. And lastly, since we can support these high throughput features, that means for 1 second we may accept like over 1,000 transactions, then the transaction fee or the gas fee in the future will be very low. So for the users, it's also quite user-friendly. When you do some payment, actually you can use our platform since the gas fee is quite low. You don't need to compare to the others to like do the to contribute to the ICO or even running the CryptoKitties and competing with others to get some digital cats. And what's next? So right now I'm showing you these ideas of sharding in Zilliqa, and we are also working very hard to release our public testnet, and we believe we can release it in a few weeks, and in the summer or autumn we'll release our mainnet. So at that time you can join our network at the beginning, because later maybe some very strong mining pools they will join, so you don't have a chance. And at the same time, we are also designing a new smart contract language. I think this part may be more interesting to our developers. Since we're from the research background, and our research lab actually figured out some security bugs of the Ethereum smart contracts using symbolic execution or some programming language ways. And at the same time, found in Ethereum smart contract, actually the concurrency issues and the concurrency bugs happened quite often, like the DAO attack and the parity wallet attacks. And so then we're planning to design a new smart contract. Now it's published in our website. It's an automata-based language, and when you write the smart contract using our language, and then we can provide another framework to help you to generate the formal proof of your smart contract. So it's like when you have your smart contract, at the same time you have the formal proof. So then when you run your smart contract, it's sort of bug-free. Since we are building this highway, at the same time we also want these high-speed cars, Ferrari, Lambo, to running on top of the highway. Right now we have the partnership with one of the largest the digital advertising companies called Mindshare. So we are trying to explore the high throughput applications running on top of Zilliqa. And in the future, we are also looking at these such applications like the shared economy application, payment networks, and even scientific computings, because they really need the high throughput to support their services. Just think that this way. So blockchain right now, especially the blockchain platform, just like 20 years ago, is in the early stage of the internet. At that time, the infrastructure is not that good, and a lot of applications cannot have their highway. However, this year or next year, multiple high-throughput blockchains will come out, and all the dApps and some interesting dApps may also run on top of it. So we can foresee some Facebook-like or Google-like and some amazing blockchain dApps will running on top of these blockchain platforms. And for Zilliqa, since just like what I said, we are providing these sharding solutions, and in the future we also would like to collaborate with other blockchains, since blockchain industry right now is quite open, especially for new community. We will seek for the possibility to collaborate and hope together we can build this amazing community, can support some Google and Facebook-like application on top of these blockchain platforms, and to have this amazing industry. Okay, thank you. For more information, you can join our Slack and Telegram. We welcome everyone. Thanks.